Hey there folks, welcome back to the Speaker Builder channel. My name is Jeff and today I'm going to provide you with part 4 of my multi-part series on building a high quality music reproduction system. If you haven't seen parts 1 through 3, check those out. In part 1 I showed you my latest project, the 3-way active system that I put together that I was so pleased with that encouraged me to go ahead and do this series. In part 2 we talked about driver selection issues and I'm giving my reasoning for why I'm making the selections that I'm making, and talking about the benefits and drawbacks of the various decisions. In part 3, we talked about crossover issues, and I gave a reasoning for my preference for the electronic crossover option. Now today in part 4, we want to talk about boxes. So we have a couple of reasons of why we're going to put drivers in a box that we need to cover actually. First one, the most obvious one, we want to mount these drivers vertically to face the listener. The tweeter actually needs to be mounted right next to the mid-range driver, so our box is going to provide us opportunity to do that. But the second reason for the box that's actually very important, these drivers, that is the mid-range and the bass drivers, are producing forward and rearward waves since the back is open. They produce, now the tweeter is sealed in the back, or I should say the driver element is completely encased in the magnet structure, so this can't produce any rear waves. But these drivers, being open in the back, do produce rear waves. And the problem there is we need to isolate this front wave from this rear wave. Otherwise, if this were just on a narrow panel, for example, and produce a positive pressure wave in the front, it would produce simultaneously a negative pressure wave in back, and that pressure wave would simply wrap around any narrow panel and cancel out the low pressure wave. And vice versa, when it goes down and produces a high pressure wave in back, it'll wrap around and fill in the low pressure wave it produces in front of it. So the front wave and the rear wave need to be isolated one from another. And so the box is going to provide us the opportunity to do that. Now, I'm not to get into this too much, but there are, as opposed to closed boxes like these, there are open baffle boxes. That's a whole different kind of a design. Most driver manufacturers, speaker manufacturers, do not produce what is called a dipole system, in which the rear radiation of the driver is being utilized, filling the room, and reflections are coming back and providing a very open sound, I'm told, by those who build dipole systems. There are a number of dipole systems out there built by other folks, hi-fi enthusiasts who are way up there, way above me, but so they're producing amazing results from those. I haven't heard them, but most manufacturers are producing, I'll call it monopole or single pole driver systems, in which the driver is intended to radiate forwards only. There's good reason for that. I'm not going to get into all that explanation. But so anyway, we're not talking about dipole systems. These are going to be monopole or single pole systems. They're going to be in a box that's going to be enclosed. There'll be no rear radiation of waves sent into the room. Okay. So now the other reason, the third reason here for putting drivers in a box, it's actually very important to understand this. If we were to look at the response curves of these two drivers, just as examples, generally speaking, a mid-range driver of this size, with an FS of resonant frequency, its lowest frequency it can really produce, down say around 60 cycles. But if you look at the response curve, as it's not being measured in a box but just on a flat panel large enough to isolate front from rear waves, but that response curve will go down to about 150 cycles and then it will drop off down to 60. And so even though it may be flat in the upper region, but it drops off early. Same thing with the bass driver. Its resonant frequency for this driver is probably around 22 or something like that, 22 cycles. But if you look at the response curve of this driver, it goes down to about 100 cycles and then it's dropping as it gets down to 20 cycles. We don't want that drop. Well, the driver is basically designed that way to be utilized in a box to support that. And so the driver is going to support this frequency response and get that response flat down, a little further down, closer to the FS. Or there'll be a target F3, a lower point at which the response begins to drop off. We call that F3. The 3 dB down point is the effective limit of the driver box system. So we want to stretch that down. 100 cycles is inadequate. In fact, the entire useful range of this bass driver is going to be 100 cycles down into the 20s. We don't want it dropping the whole time. So a box is going to support that, though. I'm just going to explain briefly why that is. If we were to generate a 100 cycle pure tone in this driver at a certain amplitude, say. And that amplitude results in a 1/4 inch of cone motion top to bottom, front to back. And then we go down to 50 cycles and we want to produce the same amplitude. This is in an open baffle, isolated front from rear waves, but an open baffle nonetheless. That cone motion will now have to be not twice as much, but 4 times as much. The 1/4 inch now that was required at 100 cycles now calls for 1 inch at 50 cycles. And that's about X max for this driver. And now if we get down to 25 cycles, now we're requiring 4 inches of travel, which the driver obviously cannot do. So for this reason, to get flat amplitude, these passive drivers that are just taking the signal from the amplifier, they can't possibly do that work at the lower frequencies. At upper frequencies, the quadrupling of cone motion is not an issue because the cone motions at the upper frequencies are so small that the driver can handle it no problem. But down at the lower frequencies, where the cone motion requirements get to be very, very, very large, down to 25 cycles, the drivers can't possibly do that. So the box is going to provide some support for that driver so that you can extend that drop-off point from, in this driver's case, 100 cycles down to 50 or hopefully down to 25 and so forth. For the mid-range driver, from 150, we want to get down to 100 or maybe down to resonance if that's the design. Now, we got to talk about box types. There are 2 that we're going to be focused on mainly, and they're going to provide all that we need for our 2 drivers. Again, the tweeter doesn't even really have to be in a box, but it's going to be in whatever box the mid-ranger driver is in. But we need to be thinking about box design in terms of these 2 drivers, or mid-range drivers generally and bass drivers generally. The 2 box types we're going to be talking about are the sealed and the vented. They are the most common in the manufacturing world of speakers. The other 2, they're kind of hybrids to the vented design, the passive radiator, and the transmission line design. I'll mention those briefly a little bit, but we're going to be starting out, first off, we're going to be focusing mainly on the sealed and the vented. Okay, so the sealed box, it's called an acoustic suspension. And so let's talk about what that means. If we think about suspension like your car that has coil springs, and the way the coil spring works, as the vehicle goes down against the coil spring places counter pressure against the vehicle as it goes down, and the further it goes down, the more counter pressure the spring produces. Likewise, as it goes up, the coil spring resists upward motion, and the further up the car moves, the more the resistance to motion is applied by the coil spring. Now the driver, when it's in a sealed box, is going to be doing the very same thing. As the cone motion moves in, it compresses the air inside the box and produces this pressure differential between inside the box and outside. And that pressure differential would push against the cone's further inward motion. Likewise, as it comes out and stretches out those air molecules and back, produces a low pressure condition inside the box. The higher pressure condition outside the box, that atmospheric pressure, will push against the driver. And so the sealed box produces, or generates rather, I should say, resistance to motion. And that seems counterintuitive that we could put a driver in a sealed box and get low frequencies extended. So what the magic is there, someone else can explain that. I haven't really gone into it too much. I'm a DIYer. I only concern myself with what works. I know that boxes work, so I haven't looked into why that is. It's kind of a little funny to think about why that is, but in any case, it works. We can extend the F3, the lowest frequency this driver is going to work, by putting it into a sealed box. We go from 150 down to 100 with this driver. Let me talk about the benefits of the sealed box. First is the sealed boxes are the smallest of the box options compared to the vented. They are also the easiest to make. There's no extra complicated aspects to a sealed box, like a vent or something. And thirdly, they provide good transient response. So I'll explain that very briefly. From the word transient, we get transition. Every driver is required in playing modern music to transition from one frequency to another virtually instantaneously. And as we talk about small drivers with very small light elements like the tweeter, it can transition from one frequency to another quite easily because the element is so small. Likewise, the mid-range driver, especially at the upper frequencies where the motion is very, 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 very slight, it can transition from one frequency to another quite easily. But as we get into the bass driver, with a very heavy element, comparatively a much heavier element, and much greater motion of the cone, as it tries to transition from one wave to another, it's going to have a little tougher a time doing that. The sealed box chamber is going to provide resistance to that motion and really help the driver to transition from one frequency to another. So a bass driver, especially in a sealed design, is known for its greater transient response as compared to the same driver in a vented design or either of the other two options. Now, the big drawback to the sealed box is that it doesn't extend the driver down all that far. In the case of the bass driver, again, its resonant frequency is down around 20 cycles. It's going to extend the frequency response from, say, 100. Remember, the bass drivers commonly drop off below 100 cycles. A sealed box will help extend that down to about 50 cycles, and then it's going to drop off after that. So we're going to talk about that in a minute as an issue, but in terms of the mid-range driver, the sealed box here is going to extend this driver's response from 150 cycles down to about 100. It'll be in that ballpark, 90, 100, 110. You will need to note that, because if you're going to make a crossover, you're going to select a frequency that's 100 cycles here between these drivers, but this driver has an F3 of 120 or 110. You're going to get a little hole there. So just note when you're designing your box system what your F3 is, what your lowest useful frequency of flat response is for your mid-range driver, and select your crossover point for that frequency. Now, I'm going to cross my system over at 150 cycles, so I'm well above whatever that low F3 is going to be for my mid-range driver. I believe the mid-range drivers that I was talking about, the Eton mid-range drivers that would match these Eton tweeters, I don't remember what the resonant frequency is, about 50, 60 cycles, but they're F3 in a small sealed chamber that they're called for, sits at around 100 cycles. So that would be a really good choice. So for the mid-range driver, our sealed box is going to provide us all we need. We can take advantage of the smaller box size, simpler and even cheaper boxes in a sealed design, and the greater transient response, although again that's not so important an issue with the mid-range driver. And we don't have to worry about a high F3 comparatively to a vented design, because F3 of 100 cycles is just fine for your mid-range driver. It's going to be attenuated below that with your crossover anyway, be it passive or active. You're going to attenuate this driver probably below 100 cycles and let the bass driver pick up everything below 100 cycles. So the sealed design is perfect for a mid-range driver, and it's being small, it's going to produce very little reflective panel like this one here, very little reflective panel on either of these boxes for a mid-range driver and a tweeter, so that we're not getting much in the way of reflections there. So that's a good benefit and a perfect fit for the mid-range driver. But now for the bass driver, we have an issue. We have the benefits of the smaller box, which are preferred by a lot of folks, and hence why we see a lot of sealed design bass systems in homes, because people want that small box. They don't want a big box. We're going to get into vented, and the vented, obviously, I'm kind of giving a hint there that the box is going to be bigger. It's going to be, the vented systems require a bigger box. But so they can take advantage of the small box size in a sealed design and have the greater transient response, and that's all good for a bass driver. But now the problem here is our target F3, our target useful frequency in which we want this driver to extend down to, is down around 25 cycles. And the reason for that is multifold. First off, the fundamental frequencies of some of the lowest notes in most music is down around 30 cycles. The lowest note on the piano, for example, is at 30 cycles. The lowest bass note on a 5-string bass that has the extra bass, the extra B string, that's lower, and that open B string is sitting down around 30 cycles. So, like me, if you listen to jazz, 5-string jazz bass players, they're playing those notes all the way down, fundamental, all the way down to 30 cycles. But the other reason for getting a bass system to extend naturally down to 30 or into the 20s. Certainly greater extension than 50 cycles, which is commonplace with the sealed design. The other reason is there's a fundamental frequency in musical notes, but then there are harmonics above and below the fundamental. And it's those lower harmonics we got to concern ourselves with, because these very low frequencies are going to be tough to reproduce. And we're going to have to look at a box design that's going to help us with that. So if you think about acoustic instruments like the acoustic bass, if you've ever had the chance, I've had the privilege of hearing acoustic bass in this room many years ago. And when you play those lowest notes on that acoustic bass, it has a to it, to each of those notes. And it's those lower harmonics that accompany the fundamental note that gives those bass notes its character and its fullness, its fatness. Same thing with drum instruments, the lowest fourth tom or the kick drum. When you hear those played, the real thing played. I played with many drum sets. I've been a player for many years. You hear those lower harmonics that accompany the fundamental of both kick drum and four toms. It just sounds awesome, and we want our bass system to reproduce those natively. So there are a couple of workarounds I want to mention briefly to a sealed design to get a sealed system that will produce flat down to 25 cycles. One of them, obviously, is to equalize it. It requires another component in the system, in the signal path, but the signal path in a biamp or triamp system is going to be in the bass system. It's not going to affect tweeter mid-range, and that would be okay. I've done that before, and you can force a sealed system driver to produce flat down to 25. But the sealed box in a bass system, to me, sounds very stuffed, very constrained, it's called tight bass. It doesn't sound natural like the bass instruments, the acoustic instruments that I referred to before. And so I want that natural, airy character to the bass. So even if you equalize it, it still doesn't sound natural. The other workaround that's very interesting that I haven't looked into doing, it's expensive. There's a cost to it, but to use multiple drivers instead of one, to use 4 or 8. The Arnie Nudell's IRS-5s that Paul McGowan shows off in his factory up there in Colorado, and he'd have you come out and visit his system. It's a $100,000 system. It's crazy, but it has 8 bass drivers per channel. So there are 16 bass drivers in the room. That's a very expensive way to go, but if you think about that, each one of those bass drivers only has to move a tiny little bit. And so you're not going to have problems with transient response, for example. And you're not going to have problems with, even in a sealed system, I believe those are in a sealed box. I don't know if they're opened or sealed. But either way, because the driver's moving so little, it'll probably produce flat down to resonance because the box is not producing a limitation. Each driver is only producing 1/8 of the full amplitude of your full system per channel. So that's an expensive option, but it is a really interesting one. So those are a couple workarounds if you want to do sealed. But we're going to move on to vented systems, and we're going to talk about vented designs. And it's interesting, I wanted to share this quick story. When I first built speakers back in the 70s, my brother and I went to a store and bought Lafayette radio speakers. He bought the 12-inch big bass drivers, and I, being the younger brother, only 1 year younger, but I was a younger little kid brother, so I bought the smaller ones. I bought the 8-inch ones. And we bought these big boxes that were customary, like the Serwin Vega boxes you saw in that video I did on those. And they're about 40 liters or 1.4, 1.5 cubic feet. Those are the boxes I got my hands on back then. Old used, they were new boxes, but they were seconds. They had flaws to them, so you could get them cheap at a warehouse. So we put that all together, because we didn't have any money back then. We put that all together. I put those 8-inch drivers in those 40-liter boxes. That's a large vented alignment. That's a large vented system. And my next system that I actually built, the Focal system, was also 8-inch 2A in those same boxes. So I'm going to talk about, so I've gotten into large vented way back as a kid starting out. And so I'm going to talk about 4 different types of vented. There's a small vented, moderate vented, which these call for, large vented, which is what I was building back then, and I've been building ever since, and then what I'll call very large vented. Now these terms I'm making up, I don't know that this is in the literature, but generally speaking, a driver, if you're going to use a vented alignment, is going to fit one of these ranges, and there'll be some flexibility within that range, but you can't take a driver that's really going to be oriented like this one toward a moderately vented and force it into a large vented. It's not going to work out. You're going to end up with problems. It'll have a bump in the response at the end or something. So you got a narrow range. Now I want to mention that you can't just take any driver and put it into any box. So that's actually very important. The driver's parameters, electrical and physical parameters, called Thiele small parameters or TS parameters, dictate the specifics of the box type. So for a sealed design, the TS parameters for this driver will call for a certain box size. And for the vented design, this driver is going to call for a moderate size vented design as opposed to a large or a small. Most of the driver systems that I built were large vented. I was selecting a driver specifically because it called for a large vented design. Many of the systems that are for sale by manufacturers, they're competing with these small boxes of the sealed design. So when they build a vented design, they're using drivers that are going to call for a small vented option. So let's talk about benefits versus drawbacks of the vented design. The benefits are, and it's the most obvious benefit, to overcome the big drawback of the sealed design. Not so much the tight base. It does overcome that problem somewhat. The greater the size of the vented system, the more it overcomes the tightness of the base, the more it provides a more airy character. That's a big benefit. The other big benefit, though, the big target one, is that high F3 of a sealed design for this speaker. Having an F3 around 50 cycles to me is not acceptable. I want that flat response all the way down to 25. If I could get it, I can get to 27, 28 usually with these 8 and 12-inch drivers, but anyway, you're into the high 20s. So we wanted, the vented design is intended to extend that F3 down a little lower. But of course, with the small vented one, the smallest option, you're not going to get it extended very far. So you're getting some extension, but not very much. But there's a big major drawback to that. Now, as we get into the larger vented, the moderate sized one for this driver, you get an F3 down in the 30 cycle range. The large vented, obviously, down into the 20s. Very large. I've seen some very large designs that will get you all the way down in the low 20s. Now, one major drawback to the small vented design is that the port, now these vented design systems require a port. This is a 2-inch type. I got a 3-inch one here. I got a 3-inch one taped up, but that's a 3-inch port. But there's a 2-inch, and you get this as a kit, and it comes apart. You can adjust you're gonna cut and adjust the length to whatever you want. But in a small vented design, the port here for this driver might only be 1 inch instead of 2 inches here. And that very, very, very small port is going to produce problems. The technical word for the audible problems that a small vent causes is known as shuff. But in layman's terms, we call it farting. But the port will do a kind of a thing. It will make noise as the air rushes in and out of the very small port. And it's the nature of a small vented design that we have these very small ports, perhaps very long ducting to the ports, and that there's resonance that can be set up in the port as well. So there's a problem. We're getting a little bit lower in F3 in a small vented design, but we're sacrificing by getting this shuff or farting going on. As we get into moderate vented designs, we solve a lot of those problems. We get a much lower F3, and we get a much larger vent called for, which alleviates the problem of shuff and resonance in the port, but at the cost of a much larger box. And then as we get into large vented, it's a significant size box. And again, for this driver, it would be a 3-inch port, a nice size port for this. You're not going to get shuff farting in this port with this base driver. It's big enough to avoid that problem. And so, but of course, again, the large boxes, no manufacturer is making those, and most people aren't familiar with them. But as I mentioned earlier, my history was to go back. I was building those by accident. I didn't even know that's what I was building. And so I just got used to that. And so it was just natural for me to build bass drivers. The first 12-inch bass drivers I bought in 1989, 90, I built 3 cubic foot boxes for them because that's what they called for. I selected them deliberately for that because it was giving me a low F3. And that's what I was after. And I was willing to tolerate the big box. So naturally, the large vented or the moderate vented alignment is ideal for the bass, versus the sealed was ideal for the mid-range driver. And one other thing I didn't mention was that with the very large vented, I don't know if there's any advantages of the very large vented, with the exception of those cases in which you get an F3 down around 22 cycles. Are you really going to be able to hear a difference between a 28 F3 and a 22 F3? But the box becomes so extraordinarily large, I think it's overkill, and I wouldn't even accept boxes of 4 and 5 cubic feet in your room, and you're going to have 2 of them. That's bad enough. I've got 3 cubic foot boxes. So again, there's a compromise here you can make with a driver like this that only calls for a 2 cubic foot box. I didn't like these in the 2 cubic foot boxes. That's why they're sitting there collecting dust. I could probably go back and build. I'd have to build rectangular shaped boxes and put the port up front, which is where they belong. In the 5-sided box, I put these in. The port was in the back. I think that may have been part of the problem, and I wasn't balancing the room for the speakers, but the bass speakers, so I know a lot more now than I did back then. But so these might actually sound okay. I could build new boxes for them. Okay, I promised to mention 2 other designs. The passive radiator is kind of an alternate form of vented box, in that it couples a driver with a passive element. It's just like the driver, usually the same size, but no motor, that is no magnet, no voice coil. And the advantage of a passive radiator is that you don't have a port to deal with, and so you're not going to get port resonance, and you're not going to get that shuff going on. Usually the passive element is located in the back of the box. Driver faces into the front of the box toward the listener. The box size tends to be not as large as the large vented. There's as large or larger than the small vented usually. But anyway, the idea of the passive radiator is you eliminate any shuffling or port problems. But the downside to a passive radiator is twofold. First, for a passive radiator design, obviously you have to have the passive radiator element. The ones that I'm looking at from SB are $100. 110, 120, whatever they are. For a $200 drive, that's an additional expense for that passive radiator. The other major limitation of passive radiator design, just like you can't put any driver in any box, you have to go with the TS parameters. For a passive radiator design, you must have a driver manufacturer that produces the drivers and the passive radiator to go with it, and will give you an internal box volume for that driver and that passive radiator. You can't. I don't know of any software that will make that determination for you. I don't know of any specs of a passive radiator that you can measure and then match it to a driver. You're really sort of out on your own to just put any passive radiator with a driver and try that and see what works. But generally, if you're going to do a passive radiator design, you buy a driver that has a passive radiator that matches it, and the manufacturer will tell you the box size, the internal box volume for that driver with that passive radiator. Now with the transmission line design, the driver is going to be placed into a long tube, and oftentimes the tube is folded into several sections inside a box. But the basic idea, I think it's a 1/4 wave in length, and that's a 1/4 wave of whatever the tuning frequency of the driver is for the transmission line design. Very complex. What commonly will happen, the driver will be in a box and it will have a chamber that will go down, and there'll be a division. The chamber will allow air to move up this way, move down that way, and then out. That's a common design for a transmission line. Usually much larger box than this. Transmission line designs tend to be the largest box type, so they're prohibitively large for some folks. They're also the most complex design. I don't know of any driver manufacturers that are producing the specs for transmission line design speakers. So you're sort of left on your own devices to build a transmission line, and there's probably a lot of experimentation involved. Again, the mathematics, I understand, are very complex, so I haven't bothered to try to produce a transmission line speaker. The bottom line for me is that I'm getting all that I need out of a vented design, and if you really want something about a slightly smaller box in a vented type of design, you go with a passive radiator, buy a drive, if you can find a driver that will include a passive element. Next, we need to talk about box type, and we're going to be addressing two types, the tower speaker type and the satellite subwoofer type. And so we got these two boxes that are going to represent those. These being satellite speaker boxes, and these are not really a tower, but we're going to use these to represent a tower speaker. So with tower speakers then, the benefits are going to be, first off, just one box versus satellite. You're going to have a separate box for the subwoofer, whether one or two. The other advantage here is generally with tower speakers, you have a very narrow panel all the way up from the floor, and the narrow panel is good because you got very little reflective surface. Not much difference here with a satellite, but that's a benefit of a tower speaker. The narrow panel is also not only acoustically good, but it's aesthetically pleasing versus a larger box that has a wide panel to it. A small footprint on the floor, obviously that's a big advantage of the tower speaker design. And proper tweeter height. We're going to set this tweeter on top. Now this is an MTM that I built, but anyway, generally speaking, for a tower speaker, your tweeter's at the very top. And so with a tower speaker being tall, that tweeter is going to be at ear height. It's going to be way up high. So that's an advantage if you choose the tower speaker design. Some of the drawbacks of the tower speaker, the internal volume here is going to be a problem. It's generally too large for a single mid-range driver, and it's generally too small for the bass driver. One of the alternatives to it for a really good tower speaker design, I've actually thought about building these, would be to have a separate, as this happens with many tower speakers, you have a mid-range driver, it'll have a separate chamber at the top of the box that's sealed off, and that's where the mid-range driver will sit. And again, if this were a normal design, your tweeter would be up top here, mid-range driver in the middle, and there would be a dividing panel below the mid-range driver to create a separate small chamber here for the mid-range driver. And then the rest would be for bass. And a really good design then would be to select, say, 8-inch bass drivers and put 4 of them. And that would give you a sufficiently tall tower speaker. Each 8-inch driver would be in a small sealed design. You have all 4 8-inch drivers in the same box. That would give you some pretty good bass. That would be an interesting design. I would like to try those. I'm thinking about doing that. But obviously with our design, we're looking at a 12-inch bass driver, unless you're going to do side firing of that, which is some tower speakers do that. They'll put a larger bass driver on the side because generally the tower speakers are very deep, and so you got more surface area to mount a bass driver on the side than on the front of the back, obviously. The second limitation, obviously we talked about limited driver size for the bass drivers unless you do 4, which is again I think a nice alternative. The large parallel side panels. We don't want any side panels. If you look at this box, what I actually did, if you can see inside here, I mounted these panels in the back, and it made the internal volume of this box smaller, but it has this side panel and this panel here. These are actually glued on into the corner, so you've got this narrow back that's like this in the back of this box. But anyway, you've got a normal tower speaker boxes. These parallel walls are parallel top to bottom, and that's a lot of parallel surface for a box. You really don't want any parallel surfaces inside a box at all, if you can help it. But so that's a downside to the tower box. This is an important issue. If you choose a satellite subwoofer design, you can set the position of these, separate from the bass drivers, and that's actually very important. And I'm still just yesterday fiddling around with the location of the bass drivers to get proper bass response at the listening position. It's a critical issue we'll talk about at a future video, but having those bass drivers in separate boxes you can move around independently of these, and then set these where once you locate your listening position and bass drivers for proper bass response, now situate your satellite speakers. for that. When you have a tower speaker that's full range, as we talked about with, say, a tweeter mid-range driver and then 4 8-inch drivers, would be a nice tower speaker design. But you've got to place those so that the bass is proper and you get good imaging. And that's, so you're getting both of those challenges you're having to deal with at the same time versus separate boxes. You have separate locations of the satellites and the base boxes. So we've already talked about some of the advantages then. One more I missed on tower speakers was you have some additional reflective surface. I don't know if that's a real big issue. I wouldn't get too excited about that. But the obvious big plus of the satellite subwoofer, as I've already mentioned, was independent placement. Here at the satellite speaker, you haven't got any other reflective surface below this, so your mid-range driver and your tweeter have no other reflective surface that they're going to have sound bouncing off and reflecting back into the listening area. Number 2, no lower box reflections. We talked about that. The narrow panel was the big benefit. I'm getting these mixed up. Number 1, narrow front panel, just like the tower speaker. Number 2, no lower box reflections like would be with a tower speaker. Number 3, adjustable tweeter placement with stands. With the tower speakers, wherever your tweeter is, your height of your tower speaker, that's it. You better build your tower speaker the right height to get your tweeter. You want your tweeter right at ear height in your chair when you're sitting down in your listening position. And if it's not there, it's kind of tough to try to deal with that. With the satellite speakers, I build my own satellite stands, but anyway, you can adjust your satellite stand height to get your tweeter height at ear height. Number 4, box sizes better match requirements of each driver type. If I'm doing the satellite, if I've got a mid-range and a tweeter, satellite box is the perfect design for this driver. And then the bass driver, we want to put it in a nice big box. And of course, I can't put this size driver in a satellite. I'm sorry, I can't put this size driver in a tower speaker. So if I want a big bass driver, there's a character to the big bass drivers that you can't get with I don't know, I haven't heard 4 8-inch drivers per channel. I don't know or even 8. I've not heard that. That would be interesting. A lot of money, a lot more money than a single bass driver of larger size. So then, of course, I already mentioned this number 5, the independent placement of the subwoofer and the satellite speakers for proper performance. And of course, the drawbacks of the satellite sub is you've got 2 sets of boxes you're gonna buy or build versus 1, and greater cost. And of course, the big sub boxes are more invasive spatially, and that some people have a big issue with that. They want as little room in your listening place taken up by speaker boxes, and you have 4 of them. It does take up a much more room. Last thing we want to talk about is box shape. And so first off, we have the 6-sided box. And the benefits of a 6-sided box are low cost, they're easy to build, and I think most people just expect this rectangular type of shape, as like with these. The downside, the major downside of a 6-sided box is you have 3 sets of parallel walls, 3 opportunities for standing waves, especially in the satellite box. Or the box that's going to contain a mid-range driver. Those mid-frequencies are going to be small enough in length that you're going to get standing waves getting set up in any 2 parallel surfaces. And with a 6-sided box, you've got 3 sets of parallel surfaces of different distances, but nonetheless. And that's why you want the rectangular shape to be have 3 different dimensions. Your width, your height, and your depth all should be different. But nonetheless, we have 3 sets of parallel surfaces, 3 sets of opportunities for standing waves. The idea is that you get different dimensions. You're going to spread those standing waves across a variety of frequencies. Then finally, my preference for a box shape is the 5-sided boxes. I've done whole videos on that. You can look at those. They eliminate all the parallel side walls. You still have a parallel top and bottom wall. But what I've done with the recent 5-sided boxes, I've glued down some material, pieces of 2x4 or whatever, that creates a non-flat surface on the bottom, so you got no top to bottom parallel surface issue any longer inside the box. There are no 90-degree side walls. that's a kind of an issue. You got a driver in here, you got these 90-degree walls, and you got reflections coming off of these side walls. And so with the 5-sided box, you've got two sides that are angled, and so you got this. It's more of a rounded shape that the driver operates inside, rather than having such the constraint of parallel 90-degree walls. The third advantage of the 5-sided box is it's more ideal externally. So here you've got that sharp drop off, you've got reflections, and then nothing, no reflections. And that step here is an issue, even though they round it off. In some of these box designs, you'll have there'll be a little bit of rounding here, but nonetheless, you've got this quick drop off here. Whereas the ideal shape, I saw a video on this from a guy presented at one of the audio shows, and he said the ideal shape was a flat panel with two 45 angled panels on the top and bottom, and two 45 angles side to side, top and bottom and side to side. All those panels off of the front panel were at 45 degrees. Difficult to build, but that would be the ideal exterior shape. So your 5-sided box starts to emulate that a little bit. And finally, I find that the 5-sided box is far easier to build than the alternative designs that involve curved panels. This was a nice alternative that gives me non-parallel side walls and a non-parallel front to back wall, so the driver isn't operating directly against a parallel back wall, creating reflections back. So that's what that was all about. A couple final things on speaker boxes. The speaker box should utilize some kind of damping material rather than just have straight bare walls internally. And I've commonly been using carpet padding. You can buy carpet padding at the big box stores in small rolls, not enough to carpet your whole house, but a small roll that would have 20-30 square feet of it or something, and not a lot of money, and you can glue those in with various kind of materials. My latest box project, as we go up next video we do for this series, I'll be upstairs in the finished room with the new system, the top of the mountain system, and the new boxes that I built for those speakers. And in those latest boxes, the base boxes, I used a water-based roofing cement and coated the inside panels with that roofing cement, and then coated the carpet padding with the roofing cement, and then glued those on, so that it not only the padding provides for some reflective, some surface that's less reflective and absorptive, but also the damping factor of having not only the roofing cement on there and then the pad glued to it dampens the panel and keeps it from ringing, because otherwise your box will ring. These are pretty dead, but the box will ring. That one's pretty dead too, but you'll have to take the front panel out. But anyway, you don't want the box to have any kind of a ring or any tone to it where you're getting panel vibration. So the inner dampening material and glued on with whatever material you have produces that both a non-reflective internal surface and some damping. Bracing can also be important when you have large side panels. You want to brace that. One of the reasons why I created this box the way I did is because this internal panel created a bracing all the way up right in about the middle of the box. Generally, the 6-sided boxes have no bracing at all. This actually has a brace on the middle, right in the middle of the box. So these side panels are braced with that inner panel. I could take this off and show you, but you want to, if you've got large panels like this, you want to put some kind of material, either piece of hardwood glued down or nailed down. I would do it diagonally here if there weren't anything inside here, to brace this panel so it doesn't vibrate and have a ring to it. So you want to support those inner side panels some way so that they don't have any vibration to them. So that's all I have for this part 4. I'm not even sure what's next up. I may do A/B testing next or whatever, but there's a number of smaller issues we need to be covering. So, and I'll be upstairs. We'll see the top of the mountain system. So we'll see you all next time.